So here's another example of a parametric equation we could graph. Notice this time we just have some trig in here. And while it starts out totally the same, the rectangular equation is going to use a different method as we do it. So notice we have t between 0 and 2 pi, so we're going to create our chart. We're going to plug t's in, then we have to plug in to x and y. So since it's 0 to 2 pi, I'm just going to take the main quadrant angles to start. So like 0, pi over 2, pi, 3 pi over 2, and then 2 pi takes us right back to 0. And now I just chose those because I know taking sine of these values and cosine of those values, it's always either 1 or -1. We could choose anything on the unit circle. You could choose 1, 2s, and 3s and get decimals when you plug them in. I just knew those would be a little bit nicer for plugging in. So, for example, we plug 0 in. So if we do 2 sine of 0, so think about your unit circle. Sine of 0 equals 0. 2 times 0 is just 0. So we know that coordinate will be a 0. Plug it into y, we get 3 cosine of 0. Cosine of 0 equals 1. 3 times 1 gives us 3 for that point. So that was our 0. Now we have to plug in pi over 2. So if we do 2 sine of pi over 2, again, think about your unit circles. Sine of pi over 2 is 1. 2 times 1 is 2, so our x coordinate will be 2. Now we need to do 3 cosine pi over 2. So we're plugging them in just like we did before using these equations that's given us for x and y. 3 times, cosine of pi over 2 is 0. 3 times 0, it's obviously 0. So we'll keep this trend going. Plug pi in. Sine of pi is 0. 2 times 0 is 0. Plug pi into y. Cosine of pi is -1. So 3 times -1 will be -3. And the last one, or actually 2 more. Plug in 3 pi over 2. Sine of 3 pi over 2 is -1. So we get 2 times -1 is -2. Cosine of 3 pi over 2 is 0. 3 times 0 is 0. Remember, you have a calculator, so you can also plug this in your calculator. Keep in mind, though, that all of those are in radians, so be careful if you're relying on your calculator, because you'd have to switch that mode up. Last one, 2 pi. 2 pi is the same as 0, so we end up with 0, 3. So if we plot all those points, we have 0, 3 as a point, 2, 0, 0, -3, -2, 0, and then it comes back up to the top. So it's moving around. Starts up at the top. If you think about as t starts at 0, it's moving around in this circular direction. So that shape should look familiar. If you think back to first semester, that gives us the shape of an ellipse. So now we want the rectangular coordinates for this equation. So if we look at our x and y's up top, in order to use the method we did before to solve for t, we would end up with t is equal to inverse sine of x over 2, which is not exactly something nice that we then want to go plugging into cosine. So we have something else here we can use. If we think back to all of our trig identities, we have a special identity, and the one that always comes back more and more, that says sine squared of any angle plus cosine squared of any angle equals 1. So we're going to use this to help switch into rectangular form. Since this equation is just a true statement, it's like saying 1 plus 1 equals 2, we can substitute in anything for sine or cosine. So, for example, if we look at our parametric where we started, we're just going to switch this around. We know x is equal to 2 sine of t. Well, I could also write that x over 2 equals sine of t. So I just solved for sine in that equation. On the cosine side, if we solve for cosine, we can write, okay, so y over 3 equals cosine of t. We'll now come back down here to our Pythagorean identity. If we know sine squared plus cosine squared equals 1, and we know that sine is in this equation is x over 2, and cosine is y over 2, we can just sub that in. So we know that x over 2 is equal to sine of t. Okay, so I'm going to take out the sine, sub x over 2 in its place, and then the square. So I'm switching my variables. Instead of theta, we're going to think of these as t's. Doesn't matter what variable we use there, that statement's always true. And we're just substituting in our parametric equations. We know y over 3 equals cosine of t from above, so therefore we're going to replace cosine with y over 3, still squared, equals 1. So now we can simplify it a little further. When you square a fraction, you just square the top, square the bottom, so we can write this as x squared over 4 plus y squared over 9 equals 1. And if you remember all those equations in the conic sections, they started out with these fractions. Remember, this meant that a was 2 and b was 3, and they always had to be equal to 1. So really that Pythagorean identity just helped us switch it into our rectangular conic equation.